Hi, everyone. Thank you for joining us today. Before we start, we're just going to real quick take about 15 minutes to make sure that the stream is going well. And just before that, if you have any questions, feel free to drop it in the chat. And just at the end of our conversations, we'll attend to it. So,
That's
yeah.
15 seconds, not 15 minutes.
Oh, 15 seconds. Yeah. 15 seconds. Make sure we're running well.
All right. Looks like we're good to go.
Okay. Hi, my name is Linda Ikechukwu, and I'm a developer advocate at Small Step Labs. And today I'm joined by CEO Mike. And here at Small Step, we're building tools that make zero trust a reality for teams and organizations with and based on open source tools. Today we're talking about security advancements that we saw in 2022 and what that would look like this year. Hi, Mike. Here to introduce yourself.
Hi, Linda. I'm Mike Malone, CEO founder at Small Step. I love talking about this stuff, so excited to be here. Zero Trust is sort of our jam here at Small Step. So I guess I can start by giving sort of a shared definition of what zero trust is, since that's what we'll be talking about. Um, the way I define zero trust is like i- it's assuming that there are malicious actors on your network and not trusting your network equipment, your network primitives, IP addresses, ACL, stuff like that, MAC addresses. So, uh, you know, sort of like red teams, it's play like you fight. Assume that they're bad actors on your network, malicious insiders or attackers, and treat your internal network traffic sort of the same way you treat traffic that is connected to the public internet. Um, so to do that, cryptography is critical, right? Because that is how you have trusted, secure communication over an untrusted network. Um, so we, that's what we do. We deliver the credentials, the certificates to enable secure communication on a network. And that's what we're going to be talking about today. Device attestation, Acme device attestation, a new standard that was developed last year, late last year in 2022, by Google and Apple, um, to deliver certificates securely to devices. So, Linda, why don't you tell us more about device attestation?
Yeah, sure. So to talk more about device attestation and the new ACME challenge that's ACME Device Attest 01, I think it's necessary to start from like the problem that this solves. And that's the fact that most MDM solutions that organizations use now um, use the SCEP protocol to aid device enrollment. Now there's quite a bit of technical details involved, but the gist is that users will get a new device and connect to an MDM server using like their corporate credentials or something. And then the MDM solution would verify those credentials and then retrieve like a one-time passcode from a SCEP server and encode the one-time passcode and SCEP server URL into a command block and send that over to um, the device, user device that requested the certificate. And then the device sends a certificate request containing the received OTP to the SCEP server. Now, the problem with this process is that we're trusting this process, trust that user credentials or that the SCEP one-time passcode will only be used on the intended device. And that's a very risky assumption to make because it can be phished. If a phishing scammer or a hacker can compromise a user's access credentials or the SCEP payload, intercepted something. And if that happens, then unauthorized users or devices now have access to get certificates from the SCEP server. And so that's where managed device attestation comes in with the device attest 01 challenge. But the word attestation means trustworthy proof or evidence about something issued by a trusted party. In the case of device attestation, you have like a secure chip or a hardware module, um, usually a TPM, within a device that provides strong cryptographic evidence about the state of the device. For example, that it is in good security posture, it is securely booted, um, certain restrictions are on the just evidence about the properties of a device, like its serial number too, or hardware identifier. And then this cryptographic proof from that secure chip can now be used in evaluating whether like a certificate should be issued to a particular device. And this is more secure than like the SCEP protocol because um, you can trust the attestation from these secure chips because they provide the way to verify the identity, and their private key cannot be extracted from them. And so you can trust that, any cryptographic attestation that these chips make. Um, so how this ties to the device attest Acme or one challenge. Last year, Brandon Weeks published a draft of the Acme Device O1 Challenge. And so before the Acme O1 Challenge, there was literally no standard automated ways for certificate authorities to leverage device attestation to issue certificates. Now, with the Device Attest O1 Challenge, an Acme server, a special kind of Acme server, can be used to authorize a certificate request. So, so in this case, to get a device using Acme, an iOS device or a Mac device can prove its identity to a third-party CA, probably like small step CA, by sending the CA device certificate signed by Apple's. Um, Thank you, Janessa, for the image. Signed by Apple, so you have Apple's attestation server, and then you have the Acme server. And so an iOS device or a Mac device can obtain a certificate from, can enroll itself to an MDN server by solving a challenge issued by the device attest Acme server, solving a device attest O1 challenge, and then uses that certificate obtained from the Acme server to enroll itself into the organization's MDM server. That's like a basic summary of managed device attestation and device attest O1 challenge. So Mike, what do you think the whole concept of device attestation and device attest O1 challenge means for zero trust? What do we see happening in this year and next year and beyond?
Yeah. Yeah. Thanks, Linda. So like Linda just said, like basically the brief summary is SCEP is a password flow, right? You're pushing a password down to the device, and then the device uses that password to get a certificate. And that's just inherently not a very secure flow. To Linda's, like Linda already mentioned, it could be intercepted. You could install that profile that has a password on a different device. Enterprise would have no way of knowing that. And device attestation is just fundamentally different. You're using a cryptographic coprocessor to sign a challenge and identify specific like UDID in the case of Apple, like a device identity, right? So why does that matter? Well, to address that issue of like intercept and lack of security on that SCEP install, a lot of enterprises end up shipping enterprise managed devices to like IT help desk and having that initial like payload, the profile installed like in a trusted environment because there's no way to do it remotely in a trustworthy way. Um, so that is a big benefit of this technology. Is it enables zero touch deploy. that's completely seamless to the end user. End user doesn't even need to know it's happening. It just happens. And it also works for remote workers, right? You can drop ship a laptop from, buy it on apple.com, ship it to your employee wherever they are in the world. And when they turn it on, it can securely enroll. It is your device that you purchased. Um,
I,
beyond
I
that,
think that
yeah, go ahead.
this is like what I just wanted to say that I think that the whole remote work thing is like the most profound like benefit, seen as like most organizations are going remote and remote work is here to stay. So yeah.
Absolutely. And, building on that, SCEP, um, it's rare to have a cloud-based SCEP install because of the security characteristics of SCEP. Most people are running SCEP SCEP, which is the protocol that this device attestation is really replacing. Um, Using Active Directory certificate services, which is an on-premise solution that, by the way, is on life support, probably won't be around for very long because Microsoft's pushing people to Azure AD, which does not have a certificate management capability. So you sort of need to bring your own. So there's a forced transition there happening there anyways. On top of that, it's just inherently uh, more secure. It gives you a strong cryptographic device identity, and device identity can be really important for enterprise access control. Right? You may have compliance or governance reasons to enforce a policy that some particular piece of information or resource is only accessible by enterprise-owned devices. And device attestation gives you a really good way of doing that. Finally, I'll say, um, because we're leveraging these cryptographic coprocessors here, in the case of Apple, they call it, their secure enclave. More broadly in industry, trusted platform modules or TPMs are what's used to sort of under the hood here. Um, what you end up with are non-exfiltratable private keys that are held in that cryptographic coprocessor that are unphishable. So you can use that credential to authenticate access to resources. You're um, pedantically, you're identifying the device. And for low security, low risk resources, that may be sufficient. You may allow device identity to stand in for a user identity. I know Linda's device is UDID 12345. And she accesses some internal website that's fairly low risk. That could be a completely transparent, unphishable, authenticated request from Linda's laptop. I know that Linda has password protection turned on her laptop, etc. It meets all of our policies. So I just allow that access. She doesn't need to log in, no single sign on, nothing, but it is secured using an unphishable credential. For higher risk resources, you could use device identity of one of these device certificates in conjunction with another form of authentication. Um, and we have a little more to say about that. So I'll hand it back over to you, Linda, to sort of discuss.
Yeah. Thanks for that detailed explanation, Mike. I think the next thing that in line with like zero trust that came out last year that caused a bit of a stir was passkeys and the FIDO and WebAuthn standards. And last year we saw like passkeys gain like traction, and that's probably something we should also talk about because I can see how it ties into the zero trust movement. So I'll just take a moment to talk about passkeys and what I understand about them, and you can elaborate on that. Um, we have the image about passkeys, but probably that could aid explanation. Do you know, sir?
I might be able to share it.
Okay.
Um,
Um, so I'll just get right into it though. Um, Now, if you don't know, the passkeys were developed collaboratively by Apple, Google, and Microsoft, kind of to get rid of passwords and promote like passwordless authentication, secure passwordless authentication with cryptographic keys. I won't spend much time narrating the problems of password because I mean the major problem is that they can be phished. So yeah, that has always been a problem, and they're just difficult to manage and remember. So the way passkeys work is that you can use like a your biometric, like your fingerprint or like your face ID, um, to like log into your website, just like unlocking your device, and it frees you from having to remember passwords. So say there's a website or an application, and when users want to create an account or sign up for that application, they are prompted for their biometrics to verify their identity. And upon verifying the identity, a public private key pair is generated for that website. Now, the public key is sent to the server, and then the private key and all other like sensitive data related to like the choosing authentication or biometric method is stored on the device and never has to leave it, or stored on in a secure cloud environment. And when a user wants to log in, they are prompted again for their biometrics to prove that they was attempting to log in. And upon like successful biometric validation, the private key attached to that website is unlocked and used to sign like a cryptographic challenge and then sent to the website authentication server. Now, the website authentication server can use this signed challenge to verify the private key of that particular user since it has the public key. Now, what this does is that it provides like an unfishable means of like authentication, because what the server or website server stores is just the public key, and uh, public keys, well, they're supposed to be public. So if there's like a server leak or anything, it's not much of a problem because an attacker can do much with it. And also because they are like bound to passkeys, these cryptographic keys are bound to like a particular website. So even if I got like a phishing email that takes me to an identical, like a similar URL, I won't be able to log in because it's tied to particular URLs. So it's an improvement from like using passwords and like 2FAs. Um, so in your opinion, Mike, how do passkeys differ from device attestation? And in what instances or situations should people be using either?
Right. Right. Great question. So passkeys, FIDO, WebAuthn, they're not exactly the same thing, but pretty much synonymous. Um, are a great new technology as well. Um, and fundamentally, just again to just sort of recap what Linda just said, like it's a very similar technology. You're using asymmetric cryptography rather than some sort of shared secret, and the private key is held in a cryptographic coprocessor. There's a lot more nuance to it, but that's good enough. A good enough sort of synopsis of how this works. So you have a like really good cover on the private key. It can't be shared. It can't be stolen by by some attacker. There in many cases, there's just no silicon to get the private key out of the coprocessor in which it was generated. So you have a really tightly bound private key to some physical device. In the case of device attestation, that's TPM or secure enclave or whatever you want to call it. That's soldered to a motherboard on a laptop or in a phone or something. In the case of FIDO or passkeys, it may be the same. Like for Apple, they do some of the stuff in secure enclave, but it could also be like a security token, a YubiKey, something like. Um, so very similar in terms of it being an asymmetric sort of challenge based protocol. Um, where it differs substantially is who you're authenticating and how. So passkeys were designed as a consumer authentication technology for the web to stop this problem, this sort of pervasive problem of phishing on the web. And they're super effective at that. So I think Google has published that they deployed security tokens, not with FIDO, but with a precursor to the FIDO standard. I think they're using FIDO now, deployed in 2014. And since then, they have had zero phishing attacks on employees that have been successful. Zero.
Well, that's impressive.
So it works. But as a consumer authentication technology, um, the protocol really bends over backwards to not identify the device that's being used to authenticate because they didn't want to create a super cookie. If you can identify my laptop, then you can associate my sessions across different user accounts, across different websites, etc. So that was explicitly not just out of scope, it was in scope to prevent that possibility. So as an enterprise technology, um, that is likely not sufficient because you often do want to identify the device. So you can think of Acme Device Attestation as sort of like FIDO or Passkeys for devices. It is this bottom turtle, unfishable, strong cryptographic mechanism for identifying a piece of hardware, whereas Passkeys do the same thing for a person.
That's great. So we have a question on passkeys, and I think we can just take that before we go on with our conversation. And someone is saying, is passkeys more suited to some specific applications over other forms of 2FA?
I would say that characteristically, passkeys are a superior form of 2FA for everything. The only thing that's holding them is, until recently, you needed a security token, a specialized piece of hardware like a YubiKey, in order to use them. But that is changing as of a few months ago. Apple is integrating passkey support into iOS and macOS, so you can use your Touch ID, Face ID to authenticate using FIDO or what's now being branded passkeys. So um, it's a seamless, very strong 2FA mechanism. I see it replacing other forms of 2FA. If the user experience can be sorted out, and I think it's been sorted out, um, I think it's just the right answer.
Yeah. I think one challenge that was like an issue early last year was losing like a device on, and I think that issue has been solved now.
Correct.
Losing your device, and then how do you retrieve your keys? Yeah.
That's right. So with that's one of the nuanced. It's not even really a change because the standard always allowed for it. The distinction between FIDO and passkey that I've read is passkey is really explicitly allowing that the sort of secure sharing of keys across like a cloud keychain. So the key, say you're in the Apple ecosystem, your passkey will be shared between your laptop and your phone and your iPad, right? And can be restored if you lose a device or something like that.
Yeah. Um, so I think we've talked about device attestation, we've talked about passkeys. Um, I do think that the next question on my mind, and probably everyone's mind who is like fan of small step, is so what's next? How are we positioning ourselves to leverage this? What are we doing about device attestation or passkeys? How are we leveraging these technologies to for the mission of making security easy for developers, DevOps, and organizations?
Yeah, yeah. I think passkeys were a big fan and we'll be leveraging them for 2FA like everybody else. With device attestation, that's a core technology that um, we're helping to develop and have built into our core technology, our certificate management technology already. So we work very closely with the folks who developed the specification. We've been working with Apple and with Google on integrations and streamlining that, understanding how people are using this, where people are running into problems. So we already support the Acme Device Attest 01 protocol. As far as I know, we're the only certificate authority. We're the only certificate management tool that can do that. That supports the protocol. Um, uh, I think what we're looking forward to, where we're continuing to develop there, is just seamless integration with MDMs. That's a big thing that we're still sorting out, looking for people who would like to partner on understanding that, who have managed device deploys. If anyone's interested in early adoption here, we'd love to work together on just understanding what needs to be synchronized between a certificate authority like ours and, something like Jamf or Intune. We're also looking forward to uh, device attestation support in Android and Chrome OS, which we know is coming. Google developed the specification, so that shouldn't be a huge surprise. And we're working on device attestation for other platforms, which is really exciting. Some, like Microsoft, for example, I think we'll have to wait for Microsoft to make a move there for it to really be a seamless experience. However, their MDM stack is more modular, and you can do this stuff now on Windows and in Linux. And we're building out better support for that. We actually see this standard as useful not just in the sort of traditional enterprise IT managed endpoint use cases, but everywhere. IoT, even VMs on the cloud have virtual TPMs now. And this is just a better way to authenticate and identify virtual or physical hardware and enroll it into an environment. It's more secure. It has really very few, or if any, downsides. So it's sort of a bottom turtle for zero trust, for cryptography, that is now standardized and available everywhere. So to us, that's really exciting, and we plan on taking full advantage of.
Great. So a question I've had most people ask is if they have a standard Acme server, can they use that for device attestation?
No. So, well, unless you're using our technology, device attestation is an extension to the Acme protocol. And for those who aren't familiar, we never mentioned this. Acme is an automated certificate management protocol that was developed by Let's Encrypt, which is a 501(c)(3) nonprofit, to automate certificate management for the web. So, like getting a certificate for, smallstep.com, you can get it for free and automate obtaining that. Um, the protocol has a few sort of hinges in it, one of which is the identity that's embedded in the certificate. Another is the challenge type, so how you prove that you own that identity. And Acme Device Attestation takes advantages of those hinges and introduces new identifiers for device ID and some new challenge types that allow you to prove control of that device identifier by signing a cryptographic challenge. So a normal Acme server, like Boulder, that Let's Encrypt uses, will not understand how to speak this protocol. You need an Acme server that has support for this specific extension.
Thank you. We have another question, and this person is asking, um, yeah, so they're asking how they've considered like options for implementing passwordless authentication for their users, and currently the costs are too high, and they're considering alternative ways to implement passwordless authentication at a lower cost. And they are wondering how Small Step can help, or if Small Step can be a solution to their problem.
Um, I'm not totally familiar with Hyper's full product offering. I think it would probably be worth more of a conversation. Although I will say that um, sounds like you're doing customer authentication, um, which is less of our specialty. We're more in the business of like enterprise IT and production infrastructure authentication, so microservices, bases, laptops, your sort of estate of hardware and software, rather than customer authentication. If cost is a factor, I will say It really depends on what you need and what you're trying to buy, but the server side of, FIDO, the core of it is really quite simple. I don't know the full open source landscape, but I would look at whether there is an open source uh, FIDO server or passkey server that is available. Really, it's not much more complicated than a password database. Um, so the technology is fairly accessible and approachable. You don't necessarily need to pay anybody to do it.
So, a question that we received before this is, what is the migration path to using Acme device attest for someone already using Scare?
Yeah, that's a good question. Um, so this is something that comes up with some of our in a lot of our customer conversations because migrating enterprise IT device management can be thorny if you don't want to screw that up. Um, but in conversations with Apple and some other larger enterprises, what you can do is roll out an upgrade. Um, so uh, rather than replacing sort of the core profile that you're pushing down to manage devices, you can sort of continue. You can push down a SCEP profile and then push down a subsequent Acme device attestation profile that sort of replaces and upgrades the issued certificate, so that in a safer manner, so that you don't run the risk of something going sideways in that initial rollout and having 15,000 enterprise IT like support tickets in your like ServiceNow or whatever because nobody can connect a VPN. So it requires some care, but there are strategies to mitigate the risks there.
Um, yeah. So, as Janessa has mentioned in the chat, if you have any more questions, now will be the time to ask. We have a few more time left, and we can take more questions. Um, okay. So, one question that we received that I have left is, can you explain more how device attest or one challenge works with a private Acme server?
With the small step private Acme server or just in general?
Um, with a small step private Acme server.
Right. Okay. Um, so we support traditional Acme and we support the device Attesto One protocol. Right now, if you sign up on smallstep.com, uh, device attest uh, um, features are in early access. Um, you could use the same certificate authority for both. It really depends on your use case and what you're trying to accomplish. We'd be happy to advise and have a discussion on that uh, if you have questions on that. But right now, to get access to the device Attesto One functionality, you need to sign up for an account and open a support ticket to request early access. Um, Now, like this is one of many provisioners, we call them in the small step ecosystem. So there are a lot of different ways to deliver certificates to different environments, Kubernetes clusters, like microservices and VMs and IoT devices and et cetera, et cetera. But as I said earlier, increasingly like this this mechanism has so many benefits. We're looking to really build off of this for a lot of other types of workloads. So rather than sort of directly enrolling a microservice, being able to identify the virtual or physical hardware that the microservice is running on using the device Attesto One Acme protocol, and then leveraging that authentication to deliver a workload certificate, things running on that device, is is very powerful. So we're moving more in that direction. So I think device attest one, I think this the new device attestation protocol really becomes this like foundational layer in a lot of PKIs.
Thank you, Mike. Um, Let me just check if you have gotten any more questions. Okay. Um, I think,
We explain everything perfectly. No
yeah,
question. Yeah.
yeah, I think we're
For me, it's it.
still,
Yeah.
yeah. And in the absence of any further questions, it's certainly time to call it a day. So, thanks everyone for taking time today to join us to dig into this conversation. For even more exciting things that like, infrastructure security that came up last year, I have a blog post about that. And um, Janessa will put that up in the chat and you can check that out later. As Mike mentioned, if you want to chat with us later about device attestation, just hit us up. Feel free to um, contact us, really. And yeah, thanks, Janessa. And we're looking forward to chatting with you and getting to know your specific solution and how we can be of help. So thank you everyone for joining and we hope to see you in the interwebs.